Hello guys, and welcome to this new recording. This time I feel like doing some kind of live coding session, and we'll be working on my HomeCtrl project, which is I think I already mentioned that in a previous video, but maybe just a quick recap just in case. This is just a project that I'm using to try to provide some kind of some level of automation, at least in my own home. And well, it's not fully dedicated to my home, of course, so I'm trying to build that in a generic way. And we have, for instance, in the HomeCtrl implementation here, we just really have one file, the main file, which is going to use other stuff that are shared components, if you want. Currently, this is still a private project. Everything here is in Nerve Home, so we have all those files here in Home folder, and so this is not available publicly. But I could consider moving that into Nerve Pro to make it public if there was some interest about that. But for now, yeah, it's just here because it was easier to keep everything in the same folder, I guess. And what I want to focus on today is, yeah, maybe just a quick demonstration first. Currently, I have a couple of water flow sensors monitoring the water consumption that I have on one side inside the home itself, and another one which is used for the garden. And so if I display the advanced settings here, you can see I have this garden flow, which is indicating what is the current number, what is the current flow of water on the garden side. And there's another one for the home flow, which is measuring the water flow in the home. And then you have the total consumption for the home reported here and the garden reported here. And I also have a grand total, if you want, summing this one plus this one, and reported here as total conso, which is the French word, I guess. So yeah, what I'm just displaying is a simple view. I just get the display of the total consumption of water. So this is pretty handy to try to monitor if maybe you forgot something up and that's not good. So what I want to do here is to actually provide a mechanism to store the value which is displayed here in a file. Because the thing is, whenever I'm restarting the system here, which is on a Raspberry Pi, this value will be reset to 0, and I would like to use the previous total consummation instead, or maybe not even directly the total consummation, but the consummation for each flow sensor. So yeah, we're going to try to add support to save some kind of state for this application and be able to restore the state later when you initialize the application only, I guess. So how should we proceed to do that? In the app folder, we have the HomeCtrl and the configuration here. We're going to in the configuration, I think I need some kind of saving delay, if you want. So let's just say delay used to save. Oh, come on. No. So state save delay. And I guess we can provide that a number of seconds, I guess. So saving every minute would be a good start. Okay, then what should we do? So the main component that we have here is a GPIO controller base. So let's have a look at this one, because this is where we actually have a loop going on, I believe. Not quite. I mean, no, you do have a loop somewhere. You have to have a loop somewhere. So where is it? Oh, it's not here. It's let me see. Monitor thread start. No, that's not the thing. Is it the manager then? Start monitoring. Okay, I guess. Start monitoring, and that's where you're going to do the monitor pins, which is a bit an incorrect name now, because yeah, you're also monitoring sensors and adding using handlers and stuff like that. But never mind. So here, this is basically the main loop, which is going to run in my application. So on every step, we're going to update every sensor, update every pin and handler, and then wait a little. So what I think I need here is a value for last save time, and let's just say that this should be none at start. And then when you are in this try loop, you're going to get the current time. Okay, if last save time is none, then you want to initialize that to the current time. But thinking about it, you could just as well initialize that here. Yeah, let's do that. Okay, and we have to read the save delay value from the configuration. And the configuration, where is this coming from? Let me see. I think we should have yeah, just a config object here, and this config is what we read here from this YAML file. Where do we read that? I don't know. I mean, really? Config is read here. Oh. You're going to set this up only on the GPIO. Okay. Not very good, I guess. Setup function, where is this? You don't actually even save this config, and you just start the monitoring afterwards. Let me reconsider that. Is this something you want to put in the GPIO? Not quite. So I guess I could just try to pass the full config here. And here you would say that this is a config object, and then you just read cfg is config GPIO, and also you're going to save the actual config itself. I mean, why would you? Yeah, this is a component, okay. So you do initialize the component, and you do have the ability to get the component and get the config from the component, but we explicitly set that to none here because we don't really want to use a default config that would be provided by all this MVP context layer. So what we can do instead is just to override this value. So in the setup here, you would say self-config is actually just the full config itself. And then when it comes to getting the save delay, you can just go and do self-config. What is the name of the value we use? State save delay. Okay, so this we can save. And this one, state save delay, it must be available in this case. Let's just say we provide a default value in case no, really it should be available. It should be specified. So we don't provide any default value. Okay, we have the save delay in second here. So we have initialized the last saved time and the current time. We do everything that we need to do here, and before waiting, actually, that's where we want to do the check, and we do something like get the elapsed time, which is the difference between the current time and last save time, and we check if the elapsed time is bigger than the save delay. Then what do we do? In this case, we should save this current state, and after that we're going to update the value of the last save time to be the current time. Yes, that should be fair enough. The only thing then, we should save the current state, and let's have a dedicated function for that save state. We don't already have that, right? Okay. So to save the current state, what we're going to do is we will prepare a dig object, any kind of mapping actually, and we're going to save that as a JSON file. To prepare this, all we need to do, in fact, is really to iterate on all the sensors, and later maybe we would have to consider doing that also for the pins, but for now I think the only case we need to save something is in the sensors. So yeah, let's try to do that. Prepare the state object, and for sensor in cell sensors values, all right, and next we just need to save this as a JSON file, as I mentioned. Where are we going to save that? We want probably just save that next to the folder, next to the config file here. So where do we read the config file from? Config dir current working directory, actually. So there's really nothing to specify. We can just use the file name as being a state.json, in fact. So what do? We just do self write JSON, I think. And we need the data, which is the state dict object, and then the file name, which is going to be state.json. All right. And that should do the trick. Apart that, we also need the save state function in the sensor class. So we have a GPIO sensor here. Just checking that we don't have this save state already. Okay. So to save the state of a sensor, most of the time we don't really have anything to do. When you have a temperature, currently I basically only have support for two kinds of sensor, temperature sensor or this new water flow sensor. And when we have a temperature sensor, there's nothing to save from my perspective yet. But when we have a water flow sensor, what I'm interested in is saving the accumulated value, which is a measurement of the consumption, the water consumption for this sensor, using the measured water flow value, and basically integrating this value over time to figure out how many liters of water have been used. So this is what we want to save. So we just need to do a check here. If self type is water flow, then we're going to save the accumulated value. So how do we do that? You just, I guess we can just use the name of the sensor here to create a new entry in the global dictionary. So we just use self name. And to stay flexible, I think I should save that as an object anyway, so that maybe later we could extend that with more data. And what you want to save is the accumulated value. This is what you currently have for the accum value, except that this might in fact not be available because you're only saving anything for the accumulated value if this is enabled. Okay, so it could also be none, and if it's none, it's never going to be really computed. So in this case, there will be nothing to save. So you basically need the same thing as here. Check that this is not none. And in this case, you save this entry. And otherwise, there is nothing to do for the other sensors or the other conditions. So that's all you need. And I guess this is it, right? Let me think. We have the entry here. We have updated GPIO manager. We have the save delay every time we do the save. Maybe just report a debug message for the moment. We can still disable that later. So let's just say logger info All right. And now let's see what we changed. We have added an entry in the config file. Here we're just updating what we're sending as configuration object. Then, oops. Yeah, most of the change are here in the GPIO manager itself. And then save state in the sensor. Okay, let's try to send that and see what is the behavior we get. Actually, there's something else we need to do, which is to read the state afterwards. So we can just push that, but it's not completed yet. How do we read the state? Actually, there is a point somewhere where yeah, we set up everything here. So we will need, before starting to setting up the sensors, to read the previous state. And let's just say, well, it should be an empty dictionary by default. And if this file exists, then they're going to read it. Okay. And then when you create a sensor, at some point here, you create a sensor. I think we could either pass the state details as part of the constructor here, or you could have a function which is load state. Could make sense. So let's just go with this way because I think it could be slightly more flexible. Load state, and you would use, well, maybe we should make that conditional. Only trying to load anything if there is an entry for that sensor. And so next we need this load state, and it's just going to retrieve the corresponding entry for this specific sensor. So let's see. We go into sensor and we create this new function. Okay. What do we have to do? We basically need to do the same kind of check, because otherwise there's nothing to apply. And on top of that, we need to check if there is this accumulated value. So we just need to do something like accumulated value. Well, I guess this is going to be another check here. And at the same time, I think we also add this previous accumulated value. So this should be updated also in this case, using whatever we have just saved as the accumulated value. And this is it to perform the loading of the state for the specific sensor. And so this should be okay now, and we should add a message. All right. Okay, now I need to upload those changes on my Raspberry Pi server. So let me do that. All right, so I have uploaded the changes on my repository on the Raspberry Pi, and this will actually automatically restart the process on this side. And in fact, I can also get access to the log file, and we can see that everything was restarted. And yeah, now we can. Oh, detected change on this file, saving current state. Okay, so the state was saved already once. So what I should probably do also is to ignore this file on the Git repository, otherwise it's going to be commented, or it could, maybe it would not hurt to comment that. So yeah, never mind for now. What we can just try to do maybe is have a look at the content of this file. And so here it is when I open that from my Raspberry Pi Access. So you can see that it's written properly and the current accumulated value is 0. Alright, and if we go on the actual application page, well, it says that the total consumption is 0, and here we have 0 and 0. Let's try to use some water and see if we can get something to increase here. Alright, so I have tried to use some water, and you see that the number here has increased. And also, if we check the state file, we see that for the home flow we have a non-zero default value now. The thing is, now if we try to restart the process again, we expect that this accumulated value will be used by default and it will not be just 0 at start. So let's try that. I'm going to do that by forcing an update on the repository and just pushing little changes again. And here we go. I have restarted the server, and we can see that by default it's still reporting the appropriate value. In fact, I was expecting 54 and we got 0.55 here. But if you check the content of the state file, you see that we still basically have 0.54, I think. It should be pretty close to the initial value we got saved, but we also have this additional small increment. And this may happen actually sometimes with the water flow sensor. Typically when I restart the application, you get a false positive at start and you have a small increment like that. Oh, and now we've been using more water from somewhere in the house. Okay. Anyway, this seems to be working just fine for me. And that's basically all I wanted to add for the moment, which mean that for now, from now, whenever I try to add new features in this application and I restart it, I should be able to keep my previous consumption value and restore that on the display, which is cool. Okay, so thanks for watching. I hope you learned something here, and yeah, see you another time. Bye bye.